Okay, so our next topic with parabolas concerns the notion of x-intercepts. And this is nothing new at all. X-intercepts, we're going to show you the geometry behind it, just like the visual geometry behind it, but you already know all the algebra to it. So x-intercepts, we tend to also call those sometimes solutions, answers, or roots. And it's pretty much the point at which the parabola touches the x-axis. So visually speaking, like if I have a parabola that does this, then this is the x-intercept and this is an x-intercept. Okay, so the points at which the parabola intersects the x-axis, those are the x-intercepts. And we find those by setting the quadratic equal to 0 and solving. So here we go, problem 6. Find the x-intercepts of this equation. Then set it equal to 0 and then solve. We just spent 5 weeks showing you how to solve these things. I'm going to solve this using the AC method. Here's my setup. Here's what I get from that. Separate and solve. However, there's one little extra step. X-intercepts are points, right? So if I have a graph like this, for example, and I have a point right here and a point right here, -2 and -1 are not a point. These are the x-coordinates of the points. So the two x-intercepts formally would be points, -2, 0 and -1, 0. And it's because we set y equal to 0. Okay, so it's really just one extra step from what we've been doing forever. And that's okay. Once you get your quote-unquote roots or solutions, make sure to put it in coordinate form with y equal to 0. For your summary, create an equation of a parabola in vertex form that has a vertex of 1, 0 and has a maximum. Doesn't matter what number you want for a, just put one that will give you a maximum. Let's take a moment to recall before we hit problem 7. Recall that when we talk about the discriminant is used to describe the roots, but it also allows us to know how many x-intercepts we'll have. So recall that if d is positive, there were two different real roots. And if you remember the graph looks something like this. And that's because it had two intercepts, one right here and one right here. So there's two different real roots. The fact that there's two different ones gives rise to the idea that there's two x-intercepts, and these two are right. Those two are these blue ones right here. So this has two x-intercepts. We said that if the discriminant was equal to 0, then it had one double repeated root. And what this looks like for us is it's a parabola that hits the x-axis exactly once because it's a double repeated root. And here is at 1 x-intercept. Okay, so it's physically, we're showing you visually the geometry behind this. And then finally, we said that if the discriminant is negative, we had two complex roots or a complex conjugate. And what this means is that there are no real roots. Now, if there's no real roots, that means it never touches the x-axis. So it could be our parabola is floating over here, or it's floating over here, or floating over here, downward, or over here even, downward. But regardless of where it's floating, it's never touching the x-axis. So what I propose to you is the following, that if we use a discriminant, we don't have to solve everything. We just do discriminant, and based on if it's positive, 0, or negative, we can predict how many x-intercepts it'll have. You should write that down somewhere, unless if you want to refer to your notes where we had the discriminant, then we already wrote that down in those notes. And just for kicks, recall the discriminant is b squared minus 4ac. And if you're not sure on how we're doing problem 7, I would suggest going back to rewatch the video where we did discriminant and we went ahead and took our time to set everything up. So here's the discriminant for part A. And if we go ahead and follow order of operations, simplify, we get 9 minus 4, which is a positive 5. So if it's a positive 5, that means that A has two x-intercepts. We don't know the value or the location of those x-intercepts. We're just identifying how many x-intercepts it has. So if the question simply asks you how many x-intercepts does a quadratic have, then do the discriminant and it'll let you know. Here's b. We get 4 minus 4, and that's equal to 0. That means it's a double repeated root, which means it only has one x-intercept. And finally, here's part C. We're not, if you're wondering why we're not saying this equal to 0 in solving, it's because we're not asking for the exact intercepts. We're just asking you to describe how many x-intercepts it has. So here's a setup using the discriminant. If we simplify this, I get 1 minus 16, which is a negative 15. We get a negative answer. Now, if it's negative, that means that this parabola is floating around somewhere and it never touches the x-axis. So this one has no x-intercepts, or if you prefer numerically, it has 0 x-intercepts. We're not saying that the value of the x-intercept is 0. We're saying it has no x-intercepts. Our final topic for quadratics and for parabolas in this particular case is something called the axis of symmetry. And what the axis of symmetry is, well, you know, if we have a parabola, right? Here's a parabola. You know the vertex is right here. If I were to draw a dotted line down through the vertex, it cuts the parabola in equal halves. We call this a line of reflection or a line of symmetry in geometry. And so what the axis of symmetry is it just cuts the parabola in half and it goes through the vertex. So this dotted line is the axis of symmetry. It's quite remarkable, really, because, you know, what's inside of the quadratic formula, we call that the discriminant. And then if we remove the discriminant, we get the axis of symmetry. So if we went ahead and took the quadratic formula and just split it up, right? It's almost like a Happy Meal. We have the Happy Meal, but one component is the hamburger, the other component are the fries. And so I'm proposing to you that the quadratic formula has two components. It has the discriminant and it has the axis of symmetry. It's negative b over 2a. So let's go for it. In part A is positive 1, B is negative 3. Remember, A, B, and C are just numbers. They're just coefficients. There's no letters. So using this formula, x equals negative B over 2A. I'm going to plug these numbers in, right? I'm using parentheses like we did for quadratic formula or the discriminant. And the B goes on top, that's a minus 3. And then the positive one goes on the bottom. Now, I'm doing this because there's a negative in front. And if you don't put the parentheses, some of you might forget this negative out here. This negative is very important because it changes the nature of the answer. Negative and a negative gives me a positive 3 in the numerator. And then the bottom I have a positive 2. So the axis of symmetry is x equals 3 over 2. What this means is if I had a parabola, for example, and I went ahead and did a line like this, this would be x is equal to 3 over 2. And then so my parabola somehow is being chopped right down the middle through that line, x equals 3 over 2. Part B, we have the A is positive 3, B is negative 1. We'll set this up again with parentheses, being careful and mindful of any signs. The top is B, so that's a minus 1. The bottom is A, positive 3. We simplify this. We have a negative times a negative is a positive 1, and then 2 times 3 is a 6. So for part B, our axis of symmetry is x equals 1 over 6. Part C, Mr. Over, why is there a pi in there? To scare you. It doesn't matter. What's A? Positive 1/2. It's also there to scare you too. And B is a positive 1. Oh, you got this, you got this. X equals, just set it up right? Set it up right, you'll be fine, you'll be fine. Okay. B goes on top, that's a positive 1. A goes on the bottom, that's a positive 1/2. So that gives me a negative 1 on top. Negative times a positive is a negative 1. What about the bottom? Well, if it helps, I can put this over 1. And these twos cancel out, so I get a 1 on the bottom. So my line of symmetry for C is x equals negative 1. What about D? Well, A is positive 3/4. B is 0. I'd like you to think about that. C is positive 5, but we don't need C for the axis of symmetry. B is 0, A is 3/4. Don't even. It's 0, right? If the numerator is 0, the whole thing is 0.